So what exactly are UVs? Well, UVs are a way of tackling a classical problem that we have in computer graphics. As you can see here, we've got a two-dimensional image, and this is based on a three-dimensional scene. As you can see here, it's a glass table, we've got a remote control and some video game boxes and so on. And our camera has actually captured that three-dimensional scene and turned it into a two-dimensional image by capturing the light on a two-dimensional plane. In other words, some film, or in a digital camera's case, a CCD. Now, once we have this two-dimensional image, we then want to convert that and actually put it onto a three-dimensional shape, you know, a cube, a sphere, whatever. And this presents a problem. And you can probably think of this problem, you know, in a traditional way. For instance, if you have a map of the Earth, then when you actually draw a map of the Earth, you will draw it on a two-dimensional plane, in other words, a piece of paper. And then if you want to make an atlas, you then have to take that two-dimensional piece of paper and map that onto a three-dimensional object. For instance, as I said, a sphere. Now, if you take a square piece of paper and map that onto a sphere, you'll find that it won't actually map on. In other words, it won't wrap onto the object correctly. So what you may have to do is you may have to actually cut the paper along its height and bottom, and then have that fold in, and eventually you'll get a sort of rough approximation of how the world actually is. Now, that's using, as I said, paper mapping onto a real sphere that we have in the real world. In CG, we can actually get away with a lot more, and we can use coordinates to actually do our cutting, as it were, for us, and then project that two-dimensional surface onto a three-dimensional object. So, what exactly is UV space? Well, if you look at this image here, we need to take this image. If I put this into perspective mode, and I'll just create a geosphere here, and I'll turn on base to pivot so it actually sits on our ground plane. If I go into the material editor and apply this texture, you'll actually see how this texture here is applied to our object. Now you can see what it's actually done is it's wrapped it around from here. You can see this is the left hand side of the image here, which we have here, and it's actually wrapped that image all the way around our sphere until it joins back up here where there's a seam. And you can see that this is the left hand side, sorry, this is the right hand side of our image. So you can see it goes all the way around the sphere, it wraps around it, which is pretty much the way I just described mapping, you know, a map of the Earth onto an atlas. Now, as you can see at the poles, you've got issues. You can see that it's pinching up at the poles, so you've got some distortion going on there. And this is typical of UV mapping. You tend to get distortion towards the poles of spherical objects. But this is something that you'll come to work with, and there are ways around it. Now, this is only what is called a spherical projection that you can actually see here. Now, as I described, there is actually a scheme to UVs. So I've actually prepared this texture, which you'll find on the DVD, and you can see it's called UVUtilityMap.tiff. And if we project that, if we put that onto our object, you'll see that I've actually created a grid on it. Now, as you can see, we have two basic axes on this grid. It's just like a graph, basically. And this is the 0 point on the graph. So basically we have the v-axis here, and we have the u-axis here. So the u-axis corresponds to basically the x-axis in other areas of CG, and the v-axis corresponds to the y-axis. So in other words, you can think of this as being width, and this as being height. There are various different ways you can think about those things. X, you could say, equals width, and in this case u equals width, and v equals height, and in 3D space y would equal height, and so on. Now, the reason why u and v were given as names for these two different axes is because x and y is already in use. And as you know, in mathematics, if you're going to do any sort of algebra, you have to give unique names to each one of your mathematical concepts. Otherwise, you're going to get a very confusing mathematical sum. In other words, you know, you can't use a plus a equals a. And you know, each one of those a's is meant to contain a different value. You would have to have x plus y equals z, let's say. Now, so early on in the in the field of computer graphics, u and v were decided on as being the letters that would actually represent these two different concepts, these two different axes in texture space. Now, the full name is UVW. So what exactly is the W. You can't really see it here. Now, W actually corresponds to Z. So if you can imagine here, we've got a Z axis and it's going down in this direction. That actually would be the W axis. Now, with 2D bitmaps, it doesn't actually come into play because they only really have 2 dimensions. They've only got a U and a V. Once you start talking about procedurals, then you actually need a third axis because a procedural very often is 3-dimensional. And in that case, you will actually need a W axis, and that's where the W axis actually comes in. And as I said, the W axis corresponds to the Z axis in the rest of CG. In other words, it's a kind of depth axis. So here we have a 2D bitmap, and as you can see, it's been applied to our plane. If I quickly go on and create some other objects, let's create a box here. And I'll create a geosphere. And I'll create a cylinder here. A teapot. Just put the segments up on that, just make it look a little bit better. And let's go for a cone here. There we go. Now, if I select all of these objects and apply the same texture to them, there you go. You can see that they've all actually got a UV space assigned to them. So you can see that each of them is actually taking this bitmap, which, as I said, is on the disk, and you can actually use it yourself. If we view the image, there's actually the bitmap that I've created. And you can see that this is actually applied to all of our objects. So each of these objects by default has their own UV space. And you can see each one of them is actually applying the UV space in a different way. You can see that the cube is actually assigning the UV space to each facet of the cube. So you've got 6 different sides. You can see that the cylinder is actually wrapping the texture around the cylinder, and then on the caps it's actually doing something else with a texture. You can see that our sphere here, as we explained earlier, is wrapping the texture all the way around. You can see there's the left-hand border of our texture, and it goes all the way around to our right-hand border. And you can see that on the cone, again, we've got the texture being wrapped around in a sort of cylindrical manner. It goes around here, and you can see at the base it's basically wrapping that texture in here. So you can see that in each case we've actually got valid UV coordinates being applied to our objects. So let's go on now and quickly have a look at how we actually display these bitmaps in the viewport so that we can actually work with UV coordinates and we can actually preview them correctly.